Hello again. Let me tell you what this video is about. I've labeled this video number 2.5 because I want to present something that in between what I presented in video 2 and what I said I was going to present in the next video, which I would label video 3. So this is video 2.5, and this is an example of compound interest, the effects of compounding, and the long-term effect of compounding. A little bit of introduction here. This example I call Og and Trog. And Og and Trog are our caveman friends, and they decide to save for retirement. Og and Trog are a little bit different. Although they're brothers, matter of fact, fraternal twins, they go to school, to caveman school, and they learn to make caveman things. And when they begin their jobs, they decide to save for retirement, but they use different patterns. Og says, I'm going to continue to live very, very frugally, as a student perhaps does, and I'm going to begin saving immediately. And so Og begins saving immediately, and he puts $5,000 away. I guess these are caveman dollars. And he does that from the age of 25, his 25th birthday, until his 35th birthday. He makes a final deposit. And then he saves no more money for retirement. So he only saves 11 years. And that's it. Trog has a different pattern, and Trog says, first I've been living very frugally, and I'm going to party a little bit. I'm going to spend some money. I'm going to buy a new Flintstone mobile, and I won't worry about saving for a while. But when Og stops, I will start. So Trog begins on his 35th birthday. And Trog saves the same amount of money, $5,000 per year. And he doesn't save it for just 11 years. He saves it for 31 years, all the way up from his 35th birthday to his 65th birthday. He makes his final deposit. And the question is, who wins? Who comes out ahead? Who is the better investor? The investor who invested from ages 25 to 35, and then the next 31 years took those years off and spent money and didn't save anymore? Or the person who saved for 31 long years, but just delayed 10 years to start? And we'll look at this through a spreadsheet example. And I have a Google Sheet that will also be shared on the classroom site. You'll be able to look at it yourself. I'm going to take that sheet and build on it, and we'll go through these processes. One thing I mentioned previously that I will mention again now because it has an effect on the spreadsheet is that these are end-of-year cash flows. So let's remember that. I'll talk about that a little bit as I work through it, but let's remember that that means that in year 25, and year 25, time passes along, right? In year 25, it starts and then it stops. It's the end of the 25th year. And that's when Og will make his first deposit, is at the end of the 25th year. So the funds available at the end of the 25th year are simply the deposit. You haven't accrued any interest because the money wasn't there all year. We'll see that as we work on the spreadsheet. I'll move rather quickly through the spreadsheet, and I will refer to a couple of spreadsheet concepts as we move along. But I will move quickly enough that it's more like I'm assuming that you know pretty much how the spreadsheet will work. So let me switch over and share this spreadsheet with you. There you see our Og and Trog Google Sheet. Our interest rate is 8%. We'll assume it's 8% for right now. And let's just look at what happens with Og. Okay, at age 25, Og makes a deposit at the end of the year of $5,000, and he does this through his 35th birthday. That's including his 35th birthday. That is 11, if you count them up, 11 cash flows. His balance at the end, at age 25, on his 25th birthday, on that birthday, he deposits $5,000, and we check the balance, and it also happens to be $5,000 because we had no interest accrued, right? He put the money in. What's the balance? Well, it's the $5,000. At the end of year 26, he has his balance from the end of year 25, so that $5,000 accrues interest at the rate of 8% per year. So that accrues interest. We will take 5,000 times 1 plus the interest rate, which is in D3, and I'll say $D, $3. And as you should know, the dollar signs indicate that that's an absolute cell address. So when I copy this formula down, that will always refer to cell D3. It won't shift the cells down as I copy the formula down. So that's the 5,000 times 1 plus the interest rate, which gives us that funds amount at the end of the year due to that $5,000. And then we add in, to get the final balance, we add in the deposit that was just made, the $5,000 deposit. So at the end of year 2, or on Og's 26th birthday, he has $10,400. And the way we've established that formula now, I can copy that down, and we'll see how much Og has in his account after his last deposit on his 35th birthday. Well, he has $83,227. So what that tells us right now is that now he's made 11 $5,000 deposits. So he has deposited a total of $55,000. And he has a total in the account of $83,227. So that means that he has interest, total interest accrued of $28,227. Very attractive. That's nice. Now, what happens to Og for the rest of the time? Well, Og's money will earn interest, right? Og's money will earn interest, but I can't get this to cooperate. But there will be no additional deposits. But I can still drag this formula down. All the deposit amounts will just be 0. And I'll go down to 65, and we'll see what Og has in his account when he's 65 years old. Wow, look at that. Almost, not almost, moving toward becoming a millionaire, right? With $55,000 total deposits. Now that's pretty impressive. So he has deposited a total of $55,000, and yet his fund balance at year 65 is $837,000. That's $782,000 about in interest. But let's see what Trog does. Remember, Trog starts at age 35, and this column here is the balance in his account. This will work exactly the same way as it did with Og. That is, the first year, the ending balance is simply the deposit that was just made. In the subsequent years, it's the previous year's balance times 1 plus the interest rate, which is in $D, $3, plus the amount that was just deposited. There we go. Now remember, We have 31 deposits of $5,000. So Trog is going to put into his account $155,000 total, $100,000 more than Og put into the account. So he should have a lot of money when he retires. Oops, went one too far. Well, now that's interesting, is it not? Trog put in $100,000 more than Og, and yet at age 65, when they might want to retire, Og has $221,000 more than Trog does. Now, as a matter of fact, if we were to continue on, and Trog were to continue to make deposits, one might ask the question, when would he catch up? When would Trog ever catch up to Og? And the answer is he wouldn't. Trog can never catch up because he waited just that 11 years or 10 years longer to start making the deposits. Now, is this dependent on interest rate? Sure, I picked 8%. The numbers would be a little bit different if I had chosen 5% or certainly 12%, but the story is the same. The secret is compound interest. So the secret is early, the early depositor gets the worm, right? Compound interest, again, the interest as it builds and you're earning interest on your interest, and the interest that you earn is so high, and then the interest on that interest next time will of course be even higher because it's on the total accumulated amount, including the interest. So Og is happy. Og had fun from age 36, from his 35th birthday on until retirement, and was able to enjoy the fruits of his labor at that point for 20 additional years. And Trog enjoyed life early and really had to pay the price later, and is still behind, and he's still behind today. He could never catch up. That's the secret and the story of not only Og and Trog, but of compound interest and its power in investing, which is why on a personal basis, and I'll be talking about this a little bit more later in the class, I really encourage you, even today, the dollars you put away today, if you don't touch them, except to maybe change the way they're invested, and I'm not talking about a savings account or an interest-bearing checking account or a money market where you're earning very little, but a real investment. You put it in there today and you don't touch it, by the time you retire, very impressive. It will be very impressive. That's video 2.5. Now I can guarantee that next video number 3, we'll talk about economic equivalence. So I hope you enjoy whatever day it is that you watch this, and I hope it's still warm as it is today as I record this. Stay tuned for video 3.